Hello and welcome back to my YouTube channel. In this video, I'll be setting up the programming environment for Arduino programming, as well as writing our first Arduino program that will blink the onboard LED. Now, when programming an Arduino board, there are two main approaches you can take. You can either use the Arduino IDE, which has a lot of pre-written and pre-installed functions to make use of, or you can use C programming and directly manipulate the registers on the board. I'm going to be taking the second approach, just because the first approach using the Arduino IDE abstracts a lot of the information that is useful for us to understand. It becomes too easy and we don't really see what is going on underneath the hood. Now, I did make reference to what is known as registers. You might ask, what is a register? Well, a register is just a block of memory that lives directly on the CPU. This means that when the CPU wants to carry out its instructions, it can access the memory very quickly. This also means that the second approach using C programming rather than the Arduino IDE will result in much faster and cleaner code. Now let's take a look at our Arduino. Here we have an Arduino Uno. Now this microcontroller here is what we are actually programming. It is known as the Atmega 328P. Along the sides here, we have a lot of pins. And these are our input and output pins. Pins 0 through to 7 lie on port D. Pin 8 through to 13 lie on what is known as port B. And pin A5 up until A0 lie on what is known as port C. Now we do also have some other pins that don't actually require us to program much. For instance, we have ground, we have 5 volts, we have 3.3 volts, and so on. Let us now take a look at the schematic for the Arduino Uno. Something important that we should notice is that the 6th port on port B is directly connected to the onboard LED. This means that when this port or pin has a high voltage, so will the onboard LED, which in effect turns it on. Now, before we begin programming, we should take a look at the data sheet for the Atmega 328P. Nobody really has all the registers of the Arduino memorized in their head and knows exactly what each register does. This is why it's super important to have a data sheet next to you at all times when programming on the Arduino. Now on page 72 of the data sheet, we can see some of the registers that are associated with port B. Now it may seem a little weird at first, but one of the registers for port B is actually called port B, but we should know that they mean two different things. Now this register is used to control whether we should output 5 volts or not for a given pin. It also does some other things, but we'll look at that in another video. Now the register port B has 8 bits. Now the bits on port B will correspond to the pins on the Arduino. So this pin will correspond to pin 8, this one to 9, this one to 10, 11, 12, and 13. This register controls the output voltage of the pins. If we write a 1 to the pin, we will get a high voltage of 5 volts. If not, we'll get a low voltage of 0 volts. Now it does do some other things, but we won't talk about that in this video. The next register is DDRB, and once again, it has 8 bits that correspond to pins 8, 9, 10, 11, 12, 13. Writing a 1 to a relevant bit will set that pin to be an output. Writing a 0 will set that pin to be an input. Now we should note here, just because we set a pin to be an output does not necessarily mean it has output 5 volts. We need to remember to use port B to output the volts. Now to program, we are going to use Visual Studio Code. There are many videos online on how to install this software. So if we just open Visual Studio Code, what we should do is move over to this drop-down menu known as Extensions. Let us then install the extension for C programming. So I'm just going to type in C. And let us install this first one. Now next we need to install an extension that will help us understand and program the Arduino. I'm going to be using what is known as Platform IO, and I'm going to install it. Now once it's installed, we'll get this drop-down menu here. This is going to help us set up our Arduino projects. I'm going to click here on Open, and I'm going to create a new project. I'm going to call this project Blink, and I'm going to select my board as the Arduino Uno. I'm going to click yes to this, and here we have our project on the side. Now the code is going to be in this src folder, our source code, and it's called main. Now I'm going to get rid of all this, and we're going to now write our program. Now the first thing we should include is a library. This library is known as AVR /io.h. Now this is going to have a lot of the features that we need to program and understand Arduino code. Now we're going to have our main function as we usually do in C. What we should now do is set the registers for DDR-B and port B. Now what I want to do is set the individual bits for DDR-B. Now one of the cool things we can do is we can write 0B. This means we have a binary value, and then we can put our digits for the rest of the bits. We want to turn on the onboard LED. Now, as we saw, the onboard LED corresponds to pin 13. From the datasheet, we also saw that pin 13 is connected to the 6th bit of port B. So we will have 0, 0, 1 to turn on that bit, and then the rest will be zeros. Likewise, we should set port B to have that bit on so that we can actually output the voltage. And just to make sure, I'm going to add some comments. Set pin, set LED pin to output. Output voltage to LED. Now, if we just run this, what's going to happen is the LED is going to turn on and it's going to stay on. Now, what we can instead do is blink the LED. So to do that, we need an infinite loop. What we can do is just use a while loop, and 1 is obviously true, so this will just run forever. And then we can turn on our LED. Now we need to somehow incorporate a delay. Now there is also another useful library which is known as util_delay.h, and with this we get a nice function that delays for a number of milliseconds. So I'm going to delay for half a second or 500 milliseconds, and then after that I want port B to be all zeros. Why? Because this will turn off the LED. And then after that, I want to also delay for another half second. Now let's save this. I'm going to go to File, Save, and now it's saved. Now the question is, how do we upload this to the board? Now once we've connected the board to our computer via the USB cable, we can go down here. This builds or compiles our code, and clicking this will upload our code. Let us first compile it just to make sure we have no errors. and that looks okay. Now let us upload it and keep watch on the actual Arduino board. Let us click upload. And look at that. The LED is now flashing. Now, just to make sure we've done everything correctly, let us change the delay to be a second. Let us now re-upload this code and see if the frequency of the LED blinks changes. And as you can see, it is quite obviously blinking slower now. Now that will be all for this video. Thank you all for watching, and I'll see you all in the next one. Bye bye.